Greetings, welcome to Problem 14. You try cost, revenue, and profit. February is a busy time at Charlie's Chocolate Shop. During the week before Valentine's Day, Charlie advertises his chocolates will be selling for $1.80 a piece instead of the usual $2. The fixed cost to run the chocolate shop totals $450 a week, and he estimates that each chocolate costs him about 60 cents to produce. Charlie estimates that he can produce up to 3,000 chocolates in 1 week. Our first job is to write a function C of n to represent Charlie's total cost for the week if he makes n chocolates. Okay, so our input value here is n. In other words, we want to find a C of n, or cost function with respect to n. So let's think about that. So every time Charlie makes a chocolate, it costs him 60 cents. So that's 0.6 times n. So in other words, that's his variable cost. That's the cost of production, so to speak. His fixed cost, which is, his overhead, his rent, his PG&E, whatever you want to say, that's going to run him $450 per week, maybe the payment on that high-end chocolate conching machine that he bought. Okay, so that's going to be his cost function. So give me the number of chocolates he makes, multiply that times 0.6, add 450 to it, and you got his cost. Now we want to know what his revenue is for the week before Valentine's Day. In other words, for his sales week. So how much money does he bring in? Well, he's going to sell them for $1.80 each, which means that his revenue function is going to be based again upon how many of these chocolates he sells. And so that's going to be 1.8 times n. All right. Cool. Got our cost, got our revenue. A little bit of capitalism 101 here. How do you determine profit? Well, profit, based upon the number you make, is equal to your revenue minus your cost. So in other words, if you want to find out how much money went into your pocket, take how much you spent, subtract that from how much you made, and that'll give you back your profit. So since we know what our revenue function is, it's 1.8 n, and we know what our cost function is, it's 0.6 n plus 450, we can give back the profit function. Now notice that they want us to simplify this. That means we have to distribute that negative there. And so this equals to 1.8 n minus 0.6 n plus 450. Okay, collecting up our like terms here, then that means our function is going to be equal to what? 1.2 n plus 450. In other words, I have $1.80, I spent 60 cents, I've got $1.20 left. That's one way of thinking about the 1.2. All right, cool. So now we know what our profit function is. Now they say interpret the meaning of the statement P of 300 equals negative 90. Well, what they're telling us here is that n was equal to 300. And so that means that Charlie only sold 300 of his chocolates. And so that means based upon this system here, if you only manufacture, so I didn't sell 300. Well, we're going to do a simplified model here and assume he sold everything, okay, all 300 of them. So if he only made 300 chocolates and he sold all 300 of them, then he would have lost $90. In other words, P of 300 equals negative 90 means he lost $90. Or he went in the whole $90. Whoosh, bad. Okay. So determine the practical domain, the practical range for P of n, and then use this information to find an appropriate viewing window for the graph of P of n. Sketch your graph from your calculator in the space provided. Okay, so what would the practical domain here? Well, they give us in the problem, they give us all the information we need for that. So the practical domain here is they say Charlie can't make any more than 3,000 chocolates in 1 week. So he can make no chocolates, that's okay. So we know that the bottom end would be 0, is less than or equal to n, which is less than or equal to 3,000. Okay, so how do we find the practical range? Well, to find the practical range, we've got to go back and reference our profit function. So knowing what well, come back up here. This is the actual one we want to reference, this bad boy. Right here, that's the P of n we want to look at. So how am I going to find the practical range? Well, I can find the lower end by evaluating P of 0. I know that'll be less than or equal to P of n, which will be less than or equal to P of 3,000. Okay, so let's get the calculator out here to help us, because we're going to have to do a bit of work on that in just a moment anyway, so might as well get it up front and center where we can use it here, okay? So clear that out. So we know that our function is 1.2 times n, so times 0, let's say, because he makes no chocolates, minus 450, and lo and behold, yes, we lost $450. In other words, he didn't make any money, but that doesn't mean he still doesn't have to pay rent and all the rest of the things that go with it. So minus 450 would be the lower end of his profit for that week. Hopefully Charlie does better than that. So let's see if he makes 3,000 chocolates, how much money he would have made. So again, this is all predicated on that he sells all of his materials. So 1.2 times 3,000 minus 450 means Charlie would have made $3,150 profit that week. So that's his upper end. Okay, now they want us to use those numbers to help make a graph and use that graph to help us figure out where he breaks even. So breaking even, that's an important concept. Breaking even means that he didn't make any profit, but it doesn't mean he didn't lose any money either. So that means his profit is 0. There was absolutely no money made, okay? So let's go into the window here. I'm going to put a 0 in for the X min, put 3,000 in for the X max, because remember in this case that n is being played by X on the calculator, okay? X scale, make that 100 just so you don't have a whole bunch of tick marks. Our Y min, well, that's our minimum profit. We know that was negative 450. Our maximum profit was 3,150. And let's go ahead and make the Y scale, oh, I don't know, let's make it 100 also, just for fun. Okay, now once I've got those window settings put in there, remember again, we press the window key to get to the window settings. We'll go ahead and press graph, and we get the following glorious function. Now they want us to come over here and give a nice representation of that graph over back on our homework sheet. So let's do that. So here's the x-axis. Here is our glorious y-axis, okay? And then I'm going to go ahead and change colors to put the graph in. We'll put the graph in red. And the graph looks not quite unlike, but similar to that, okay? So there's a good sketch of it. Now, a graph should be a self-contained document. And what that means is that all the information necessary to interpret the graph should show up on it. So we're going to put over here on the horizontal axis n, which is the number made. So that's how many chocolates he produced, okay? And then over here on the vertical axis, we're going to put a P of n, which is profit. Because we know Charlie's a good capitalist, right? So that's his money. So one other thing that would really help our viewing public is if we actually put in the numbers that delineated the ends of our axes. So negative 450 down here in the bottom of P of n, and 3150 up here on the top. And then over here is 0 on the end, out to 3,000 on the end. Not 300, like 3,000. There we go. Okay, now, based on a graph, we want to figure out what that number right there is. In other words, they tell us how many chocolates must Charlie sell in order to break even. Show complete work. Write your answer as a complete sentence. Mark the break-even point on the graph above. Now, you can use the calculator to do it. There's a couple of fancy ways of doing that. But let's do some algebra instead. So the break-even point, what that means, what break-even, when you see that, break-even means that the P of n in this case was equal to 0, no profit. So give ourselves a little more room to work here. What that tells me is that 0 is equal to 1.2n minus 450. In other words, that's where the profit's equal to 0. That's this point on the graph. So take 450, adding that to both sides, right? And then dividing both sides by 1.2 gets me back an n. And then if I do that simplification, I get back 375. So at 375 chocolates, I see that Charlie breaks even. In other words, his profit is equal to 0. Now they want us to mark that break-even point on the graph. So let's do that. So that point right there is 375 by 0. Okay, there's a lot of good stuff in that problem. That's actually some good real-world sort of application. It's the beginnings of econ. So hopefully you got that. Again, if you didn't, please post me more questions in the Q&A forum.